Hello, everyone, and welcome. My name is Lloyd Albert. I head up Public and Government Affairs at AAA Northeast, headquartered in Providence, and I also have the distinct privilege of chairing AAA's National Public Affairs Committee. Early on in this pandemic, AAA clubs across the country pivoted quickly and began to sponsor outreach events on a myriad of topics targeted to their members and other stakeholders. Here in our 5-state area, stretching from Massachusetts to New Jersey, our wonderful team has hosted over 300 live events since March that have been enthusiastically received by our various audiences. Our event today is really an expansion of these efforts, and one that for the first time for us includes a national audience. Regarding today's program, AAA's research and engagement in the area of vehicle automation has been ongoing and focuses primarily on its long-term impact on mobility and its far-reaching traffic safety implications. That said, we understand the deployment of autonomous vehicles must occur through thoughtful coordination between automakers, highway engineers, the technology community, and of course, safety advocates, all in an effort to ensure that the safety of the American public remains paramount. To delve more deeply into the subject, we're pleased to be joined today by Michael Graham, one of the 5 board members on the National Transportation Safety Board. Member Graham is the 45th member of the board. He was nominated by President Trump late last fall, confirmed by the U.S. Senate, and began his term as an NTSB board member in January of this year. We are equally pleased this afternoon to have Kathleen Bauer moderate the conversation with Member Graham. Kathleen serves as Senior Vice President of Public Affairs and International Relations for AAA out of our Washington office. She directs all public affairs activities for the 60 million member organization, including government relations, traffic safety policy, public relations, and international public policy, and also oversees AAA's Foundation for Traffic Safety. Now, before I turn it over to Kathleen to begin the conversation, let me just take a moment to acknowledge the outstanding support that AAA Northeast has received from the NTSB's expert leadership over the past decade or two. With sometimes no more than a phone call or email request, we've been joined at state houses in Boston, Providence, and elsewhere, or at a variety of safety summits by board members Robert Sumwalt and Jennifer Homendy, and dedicated advocates like Stephanie Shaw, Steve Blackstone, and Leah Walton, among others, standing shoulder to shoulder with us as we testified or otherwise advocated on thoughtful laws that save lives and reduce injuries. We really deeply appreciate the collaboration that has been a hallmark of our relationship with the NTSB. To all of you in the audience today, your microphones have been muted by the host and your cameras are off. To pose questions to Member Graham, please type them in using the chat function, and we'll try to get to as many of them as we can in the time allotted. So now let me turn it over to my colleague, Kathleen Bauer, for what I'm sure will be an interesting and engaging discussion. Thank you.
Thank you, Lloyd, and good afternoon, everyone, and welcome, Member Graham. Thanks so much for joining AAA today for this virtual town hall meeting. Now, Lloyd gave us a real high-level snapshot of you and your background, but there's a lot more beneath the surface. I wonder if you could just tell us a little bit more about your background and how your experience lines up with the important work of the National Transportation Safety Board.
You bet, Kathleen, and thanks again for having me today. I've been really looking forward to this. Basically, before I came to the board, my entire career has been in aviation. It started as a naval aviator, flying A-7s and F-18 aircraft off of aircraft carriers. Things that I did in my Navy career, besides flying, were overseeing avionics and armament divisions, also training, occupational safety and health programs, and other safety programs, and then also training new F-18 pilots to go out to the fleet. From there, I spent about 9 years in the Navy, and then I moved on to be a military contractor with F-18 programs. I did everything from training training the fleet pilots out there, to marketing the aircraft, not just to the US government, but to foreign governments. And then I was an avionics integration engineer with new technologies going into the follow-on models of the F-18, the E and F models. I did that for about 2.5 years when Cessna called me in Kansas, and I moved out there and spent the last 22 years with Cessna Aircraft. Eventually, we bought out Beechcraft, so we became the largest general aviation manufacturer in the market, and eventually we became Textron Aviation. I did everything from demonstration pilot role to production flight testing pilot, and my last several years I was the director of safety, security, and standardization for all the flight operations, and that covered everything from aircraft certification of our new models, defense flying of aircraft we flew to the defense sold to the Defense Department, production flight testing, demonstration flying, production flight testing, and even aircraft management. And in that role, I spent some time with the industry working on safety of single pilot operators, general aviation pilots, business and corporate pilots. I spent time working with the Air Charter Safety Foundation. I was the chairman before I came to the board, all in a voluntary role trying to improve charter aviation safety record. And then I spent some time working on a group called the Information Analysis Team, looking at general aviation safety issues with the FAA, again in a voluntary role. So I bring a lot of safety background, but it's been all aviation to the role here. So I'm trying to transition that to all these various other modes of transportation here at the board.
Well, there's just no doubt that that background must position you very well. I can see why the NTSB considered you valuable and why you are where you are, especially with what we're going to talk about today, because I think a lot of your background is probably transferable to surface transportation, to different modes, especially that training piece. Well, AAA is counted on the National Transportation Safety Board. We counted you as a very important partner in traffic safety for decades, and Lloyd expressed our appreciation to the staff and to all the members of the board earlier. You're a very highly respected organization, probably best known to the American public for aviation accident investigation, but there's a lot more to the role of the NTSB, isn't there?
There sure is. You know, if you look at our mission there, is we're there to investigate crashes, accidents, and incidents, and basically determine the probable cause of each of those. Although our mandate specifically says we will do all aviation accidents, we also do select accidents in all the other modes, one of those being highway, obviously, rail, major marine accidents, pipeline accidents, and then any kind of hazardous material release as related to transportation. We look at those. We also do designated studies, safety studies, looking at transportation safety problems out there. And out of our investigations and our safety studies, we actually formulate safety recommendations to improve transportation safety. These are our products, so to speak, other than the probable cause. These are our product. I got to remind everybody that we're not the regulator out there, but our recommendations go out to regulators. They go out to manufacturers, companies, operators, trade organizations, just to name a few. And we do that in hopes that if they take our recommendations and implement them, they're designed to prevent future accidents, similar accidents, hopefully reduce injuries, and more importantly, save lives.
Yeah, well, that's great. And when I first started working with the NTSB, that was really great stuff to learn, because it's not kind of what the public thinks about the NTSB for, but such great work done there every day. And of course, we've worked with the NTSB for decades on surface transportation safety issues, many issues: distracted driving, teen driving, impaired driving. And together with other safety stakeholders, we've done important work together to improve transportation safety. But today we're going to spend most of our time looking into the future and talking about vehicle automation, which I think we all agree has a lot of potential to improve safety on the roads, but getting it right also has some challenges. But before we talk about these new technologies, we've just lived through a major national crisis. Actually, we are still living through it. That's resulted, of course, in the tragic loss of life, unprecedented economic disruption. But the pandemic has also changed our lives in so many other ways. Where we work, how we drive, our use of mass transit. With dramatically less driving, I would have thought that road safety would improve, but is that the case?
No, maybe not exactly. You know, this whole COVID-19 coronavirus thing is really, I mean, it's really turned all of our worlds upside down, hasn't it?
Mm.
And you know, and my heart goes out to families that have been affected by this, especially ones that have lost loved ones. I can't imagine. I look at the families in my neighborhood, and a lot of them are working from home and trying to teach their kids at the same time. I am just so happy that I don't have school-age kids anymore. Mine are all grown up and out of the house. So, but yeah, this thing has been something else. Yeah, we've looked at the data out there, and we've seen some, you know, some disturbing data coming out and some trends out there. Even though we know that the traffic volume has reduced significantly, especially in the first part of 2020, we do see crashes down, fatalities down, but what's so disturbing is the fatality rate has gone up significantly. And so we're trying to look at the data out there, the state and the national data, and we're seeing some factors that are contributing to that increase in the fatality rate. There's three of them specifically that I've noticed, and one is there's evidence of increasing ejection rates of vehicle occupants, which means we're not buckling up when we're driving. You know, have we not learned that lesson yet? I can't believe anybody gets in a car or vehicle anymore and doesn't buckle up. The other one is, and I'm sure it's, I've seen it on the news quite a bit, I'm sure you have too, is speeding is more prevalent now. And I don't know if that's because of the reduced volume of traffic. I know I've had people blow by me going down 395 because I've been driving into work quite a bit during this shutdown period. I don't know if it's, you know, law enforcement has reduced their exposure out there to stay clear of this. Not really sure, but there is definitely an increase in speeding. And then there's evidence out there that there's increased driving under the influence. And it's just not alcohol, but it's marijuana and opioids. I'm not sure if people are doing that to cope with the stress of this pandemic, but we do see an increase there. And we're going to continue to look at these trends, and we're going to continue to advocate for, you know, buckling up. Don't drive under the influence. Slow down. Follow the speed limits. Don't drive fatigued. You know, we've done hundreds of crash investigations over the years where these issues were the causes or contributing factors to the crash. We've done plenty of safety studies and special investigations in this area, and we put out countermeasures to address these things like occupant protection, speeding, impairment, fatigue driving, things like that. So, you know, we haven't stopped doing our job. It was very tough when we first kind of got shut down. Most of us are teleworking, but we're really getting back out in the field, but we didn't stop doing crash investigations. We relied on the local law enforcement and local officials to get the evidence for us, but we're going to continue to investigate. We're starting to get out there a little bit more now that we know more about the virus and we can do it safely. We're going to continue to learn from these investigations and hopefully learn more about automated vehicles. And we're going to provide science-based recommendations on how to reduce these crashes, reduce injuries, and hopefully save more lives. But as you know, changing human behavior can be very challenging. So that's why we're looking to the technology to help us out here, especially collision avoidance system technology, to be part of the solution.
Yeah, it's amazing how it comes down to those three, you know, kind of perennial problems of belts, booze, and speed. And you just wonder when we're going to be able to get that right. But those are really persistent problems. And as you said, we don't really know what's at the root of those things. Maybe it's stress and alcohol and drug abuse. the less crowded roads that just apparently tempt people to speed. But as you pointed out in our segue to what we're going to talk about today, those are all driver-related problems. They're behavioral, and that's the tough part of the safety problem. And as you said, we really are looking at technology to reduce the driving risks in the future. Can you tell me about the vehicle technologies that the NTSB has advocated for and how those technologies relate to automated vehicles of the future? Are they building blocks?
Yeah, very good. Yeah, you know, we've been looking very closely at this, and we know these systems out there that are partial automation systems out there that we're looking at. That's what we need to stress to people. They're there to help them do their job, right? They're there to help them do the drive. They're not to do it all for them, and they need to stay engaged and monitor everything. You know, we know a lot of crashes are caused by human error. Humans are not perfect. None of us are. We make mistakes. We make bad decisions, you know, such as some of the things I talked about: DUI, fatigue, distracted driving, things like that. And we hope that, and we think there's a lot of promise in these collision avoidance technologies to potentially reduce the number of crashes and injuries and fatalities coming down the road. I think some of AAA's research itself out there shows that some of these technologies like forward collision warning systems, automatic emergency braking systems, lane departure warning, blind spot warning systems has a potential to significantly reduce and prevent many of these crashes. You know, we've been advocating for collision avoidance systems on new cars and trucks for over 25 years here at the NTSB, and the progress has been considerably slow in these areas. You know, a lot of it, I think, is from the lack of regulatory action and the development of specific performance standards for the technologies. You know, and we look to the National Highway Traffic Safety Administration to do that, and we feel they've been pretty slow. We're on them quite a bit there. Also, the existing testing scenarios that they're using to evaluate cars out there and the protocols for these assessments are just don't accurately or adequately represent what's going on the highway out there. So we're reaching out to NHTSA to expand those in these areas. As you know, all these systems use radar and cameras and LiDAR sensors out there, and for these, what I would call partial automated systems for forward collision warning systems, automatic emergency brakes, lane departures, and lane keeping. And yes, they are the building blocks. They are the foundation of what a fully automated vehicle is going to be using in the future. So we really need to get it right here. And that's why we're really calling out for NHTSA to step up and start testing in these areas. One of the areas we're really leaning on is the new car assessment program. One of my first board meetings was a Tesla accident in Mountain View, California. And I learned so much that first couple of months here and going into that board meeting about the new car assessment program. And if you look at what the US does, we only talk about front and side collision and rollover. That's the only thing we rate, NHTSA rates in the new car assessment program. If you look at the European new car assessment program, they go through all these new technologies and they're constantly expanding, and they're a very easy to use, consumer oriented assessment program to read the ratings and educate yourself on what you're buying and what you have or what you potentially may buy. You know, new car assessment program started in the US. The European model Europeans looked at us and started theirs, but they have significantly bypassed us in this area. So we're really pushing on this because that's one of the only places that consumers can go to educate themselves on this new technology. Although I know you guys have done a great job at AAA trying to help educate the consumer, and hats off to you.
Well, thank you. And really, as we study it and learn more about it, we come to the same conclusions that consumers have to understand these systems. They have to understand how they work and how they don't work. And it doesn't help that there's an awful lot of hype about automated vehicles out there. And so you and I today are going to dig a little and focus on facts. On any given day, the public might hear in the media that fully self-driving vehicles are here on the ground running today. In fact, earlier this week, Elon Musk, Tesla, announced that Tesla will have a fully self-driving vehicle in beta test with expert drivers starting next Tuesday, the 20th of October. But you know, you're as likely to read or hear that we're 15 to 20 years away from mass production of fully self-driving vehicles. So I think it's really hard for the public to understand and make sense of this. What do you think? Where do you think we are on that spectrum of fully automated driving? I mean, are we just decades away, or are we actually on the road?
You know, I can't predict when we're going to be there. I will tell you though, we're not there right now.
Yeah.
Even with what Tesla is putting out there as saying fully automated, it's not. There are significant limitations to it and conditions that you should not be using that kind of technology at this point. So there is no fully automated self-driving car out there. I want everybody to be clear with that. How far off we are, I'm not sure yet, but we got to get the partial system down before we get the full automated system down. You know, there's a lot of testing on this automation that still needs to be done. A lot of it's being done on our roads, unbeknownst to most people out there.
Right.
And we just got to remind people that do buy these systems or have these systems that you still need to stay engaged. You still need to be monitoring it all the time. And please, if something's not working correctly or you're not sure what it's doing, it's time to turn it off and take over manually. You know, I look at these as these are what I call engineering controls to human error problems. And just think about it though, we're trying to eliminate human error, but we're using technology that's developed by humans. So there are going to be some errors there. And I just look into what's required to program the computers of this technology in these cars. It's, you know, they've got to be prepared for all the different kind of driving conditions, changing environments, dynamic traffic conditions. And then this is even more challenging when we talk about some of these speeds at you know, when you get on a highway at the higher speeds. So just looking at the amount of research and testing still needs to be done. You look at the average time somebody owns a car out there, you look at the length of time to implement a safety feature and actually achieve a market penetration with some of these technologies. It's going to be a number of years before I think we truly have a fully self-driving vehicle. You know, I just read the other day, the average life of a car is about 11.5 years now. I think it used to be 8 years ago is the number I used to remember. You look at what it takes to have a safety feature penetrate the market, it usually has to be a standard feature. And I think the last standard feature, safety feature, was the rear backup camera.
Mm-hmm.
You know, and that right now, I think I saw numbers that it's just past 50% penetrated, and that's because it was mandated in, I think it was May of 2018. But if you look at automatic emergency braking systems, there's less than 5% of the cars registered out there have it. I think data says by 2023, maybe be 23% by then. So
Yeah.
Something that I've read. So I think we're a ways off still.
Yeah, I tend to agree with you. And you raised such an interesting point about the technology is being built by humans actually to replace kind of the human judgment that happens. Driving is such a complex task. And honestly, it's very, very hard to recreate the human brain and all of the things when we're focused and paying attention and not distracted and not impaired in some way. Human brain is pretty hard to recreate with technology. So to your point a few minutes ago, you were saying we do not have fully self-driving vehicles on the road today. And I actually think that there's probably a lot of people who kind of think, oh, well, some of these cars are driving themselves. In reality, what we know that we have are vehicles on the road that have active driver assistance systems. And those are things that assist drivers who are still active and engaged in some situations, and they don't drive themselves in every situation. In the past, the NTSB has investigated some very high-profile crashes, and you mentioned you were involved with one when you first came on board. And those crashes have included those in operating with some of these partial driving automation systems, including a few on Tesla, which have a system that sounds a lot like what's been part of the aviation world for decades. Their system is called Autopilot. So, Member Graham, the NTSB has released several reports on these kind of crashes. Can you tell us about some of the important lessons that have been learned in these investigations that are going to help us as we make this transition with this technology?
You bet. Yeah. Let me reiterate again. There are no fully self-driving cars on the market yet. Yeah, and we have seen this from some of the accidents we look at. Specifically, we in the last couple of years, we've looked at 4 Tesla accidents, and there's a reason we looked at them, because we knew this is an emerging technology out there, and we wanted to try to fully understand what the issues were with this technology. So all 4 of these accidents we looked at with Tesla involve partial driving automation. Let's get this straight, that that's to help provide lateral and longitudinal control, but it has it can only be operated in certain conditions and has a lot of limitations to it. We got to remind people. So what we're talking about, partial automation, is the I think the Society of Automotive Engineers call it level 2, right? Level 2 automation. So what does level 2 require? It requires the driver to monitor the automation at all times, maintain situational awareness of the traffic conditions. It also it requires the driver to understand the limitations of the automation, and when all else fails, the driver needs to take over and intervene at any time. So people need to understand it. So it concerns me I read the same thing you did and what Tesla's putting out there. It's very concerning because we're not there yet. So out of the investigations, what are some of the others? What did we learn out of this? Well, we confirmed, one, drivers are pretty poor at monitoring the automation. We found that in aviation too. We spent a lot of time teaching pilots how to monitor automation over the years. So it's nothing new from my standpoint. We also found that people don't perform tasks that require passive vigilance very well. What happens is we become disengaged, which is exactly what we saw in all 4 of these accidents. All 4 of them, they were on the so-called autopilot mode, which we know is not truly an autopilot, it's a partial driving automation. And we know by the data that we've seen that all the drivers were pretty much completely inattentive and completely disengaged from monitoring the system. My first board meeting was the Mountain View, California accident of Tesla, driving south on Highway 101 in the left-hand lane. This driver had driven this route many times. He was driving from home to work, I think after dropping his child off at school. Unfortunately, what did we learn? I said the driver was completely disengaged. We found out that the driver was actually playing a video game on their phone while going down there, was disengaged for a lot of minutes while going down that road. The system, unfortunately, actually lost the lane assist didn't lose it, but it lost the stripe for the lane on the left side, right where they were coming into a diverging highway, basically an exit ramp on the left side. And the vehicle started moving to the left into the gore area that had no striping because there's no stripe. The vehicle had slowed briefly from what it initially had set as speed because it was following the car in front of them. When it moved into this so-called open gore area, it actually started accelerating back to the speed that the driver had set. We do know the system did see the concrete barrier where the divergent highway was ahead of it, but it didn't register it as a hazard. So it went into it full speed. The driver wasn't engaged because we didn't see any braking on part of the driver or any automatic emergency brake system, and unfortunately lost her life. The sad part of this is we found this driver actually had spent considerable amount of time doing YouTube videos and trying to understand the automation, and probably knew it better than most consumers do, but yet still became completely disengaged and stopped monitoring the vehicle, which is unfortunate.
Wow.
We've seen this in the other 3 accidents, because there was no response by the driver. There was no response by the automatic emergency braking system for crossing traffic with the tractor trailer truck, 2 trucks, a fire truck in a lane ahead. The system recognized it but didn't register it as a hazard. So that's a huge issue. So what are we, out of those investigations, we've made some recommendations. One, to NHTSA to work with the Society of Automotive Engineers International and develop some performance standards for driver monitoring systems and require them on the new vehicles. We're already seeing people completely disengage, even though they're supposed to have some kind of monitoring system to where if the driver's not engaged, it's supposed to kick the automation off, right? That's not happening. We've made recommendations to the manufacturers and NHTSA to incorporate some of these system safeguards for that, and to also limit drivers from using the automation in driving conditions they're not supposed to. That's a much more difficult task out there. So we'll see where we go on that one. And then we'd also see some more things on the data recorders that all these vehicles now have. We'd like to see some defined data parameters for us that we could use, but hopefully not just for crashes, but hopefully the manufacturers are looking at this data to make the systems better.
Yeah. Well, thinking also about another investigation that I believe that the NTSB has conducted on the Uber test vehicle that unfortunately hit and killed a pedestrian. And I think one of the things that your investigation pointed to is the need at the company, at Uber, that they needed to develop a culture around safety and clear safety protocols. So how should these companies create a safety culture, and is there a role for government to play in promoting that safety culture in the private sector?
Yeah, that's an excellent question. We back in 2018, we went out and looked at the accident out in Tempe, Arizona, and we responded to a crash of the Uber that had struck a pedestrian crossing multi-lane road mid-block. We basically determined out of that the what I call the safety driver, the safety observer, wasn't actively monitoring the environment and what was going on, and actually was watching a video on the phone. And when this all happened, we were aware that, again, the system did see this pedestrian crossing. I think they had a bicycle also with them, but they were walking it across. They didn't. We did see in the technology that it was trying to figure out, is this a hazard, is it not? It did within less than a second, I think it was like a half second or so, start the braking, but it was too late. Unfortunately, the pedestrian lost their lives. So we know the contributing factors to this was just not the monitoring, but Uber had inadequate safety risk assessment procedures for that operation. They had no ineffective oversight of the vehicle safety observer. There was a lack of mechanisms for addressing this during the development, and then there was insufficient state oversight in these cases. So we know there's, these systems aren't perfect. There's a lot of failures and limitations to them. So it's absolutely animately required that they have just solid risk management systems out there, risk assessment systems for this testing, and that what that requires is a very positive safety culture in the company to address these. So in the absence of having safety regulations and federal guidance out there, we really are asking states to help develop some of their own testing requirements out there as they go along.
Yeah.
The thing is, there is some guidance out there by NHTSA how to do a safety self-assessment on these when doing these types of testing out on public roads. unfortunately, they're only voluntary. They're not mandatory.
Guidelines, yeah. Well, so certainly the companies then have that responsibility for really doing the testing safely. And it seems like we're always trying to kind of work the human out of the equation, the human being the big variable there, even in that really unfortunate crash in Arizona. From our own research, AAA's own testing and our AAA Foundation's research, we really have in academic studies found a lot of the same things that you have seen in these actual tragic accidents. One thing that's really central to what we found is that it's important, and the best time to educate consumers about the capabilities and the limitations of these driver assistance features is early in their exposure to them, when they're still cautious and they're still maintaining good focus on the road. So before they form habits over relying on them, which you certainly had, you saw that in those crashes that you've investigated. The other thing that we found in some recent work, in fact, that was just released in September of this year with Westat, is that words matter, and they matter a lot in terms of how these systems are described. And that's in the marketing materials and the education materials from the vehicle manufacturers and what the dealer says too. If the name of the system sounds like the vehicle can drive itself, consumers are more likely to think incorrectly that it can drive itself. And as we've said here multiple times, there's no vehicle that really can drive itself all the time. And then we do know what you have found from these crashes is consumers using these systems put too much trust in the technology, and they can quickly become complacent about watching the road. So it's critical that consumers understand the limits of these systems so that they don't over rely on them. Member Graham, what are some of the things that you think we need to get right before the general public can really buy into the promises made about automated vehicles?
That's an excellent question. I've looked at some of your last couple of years of your annual survey of the automated vehicle survey, and it's interesting to see that I think in 2019 that 71% of those surveyed were afraid to ride in a fully self-driving vehicle, and that went up from 64% the year before, which is very telling. And I don't know if that survey was skewed a little bit from, it came on the heels of several of the accidents that we looked at, or several of the crashes we looked at right before that. So I think if we're going to increase consumer confidence in these areas, it's got to start now with the partial automated driving systems with the level 2 out there. If companies continue to take shortcuts, don't look at the safety risk assessments, I think we're going to see more crashes out there with these partial automated driving systems, and it's just going to continue to lower the confidence of the public in automated vehicles. So I think this complete hands-off approach that NHTSA is doing right now with no oversight, no performance standards out there, I think it's just going to result in some more crashes. I hope not, I really do, but I think we're set up for it. And I'm concerned about the testing of these automated vehicles on our public roads. A lot of people are not aware this is going on at this time. So we really need to require that these companies have a robust safety risk management procedures out there and a very good safety culture, because it's not going to provide any confidence if we continue to have crashes. And I think the biggest thing we can do is educate the consumer out there. That's the biggest thing. Make sure that they understand these systems, how they work, what conditions don't they work in, and what limitations do these systems have. That's the only way we're going to be able to increase the confidence in automated vehicles.
So you come to the NTSB with such a rich history in aviation safety, which has an excellent safety record compared to other modes of transportation, certainly highway safety. And I can imagine that a lot of that experience that you have with pilot training and the use of automation in the aviation context, I imagine that there's a lot of things that are very similar. So what would you say are 3 key lessons from the successful use of automation in aviation that autonomous vehicle developers and policymakers need to know and think about?
Kathleen, that's a great question. Yeah, I know something I learned very early on when I started flying was, I remember instructor pilots were always telling me, be ahead of the aircraft, you know. And what they meant was, you need to expect certain things to happen ahead of you and be anticipating these things from happening, for these things to happen. So, you know, especially with automation, and aircraft have become highly automated now, you need to constantly manage the systems. You need to be constantly monitoring the systems. And if something is not working the way you programmed it to, it's not doing what you expect it to do, it's the time to get out of that level of automation. So kick it out. If it's not doing what you want, get out of it right away and go to a lower level automation, or just manually control the aircraft at that point. I think that's very critical. Then there was something else that I saw in the last several years with all the automation we have out there. The autopilot systems in these aircraft are quite incredible. And as a matter of fact, the FAA has designated a lot of the airspace where these aircraft normally cruise at, you're required to fly on the autopilot system, because they maintain the altitude and the course much better than a human can actually do. If a human were to do it, they would be constantly engaged, and it's very fatiguing. So they require this. So what happens is, we saw pilots becoming very dependent on the systems. And I don't know, you may have heard some of this over the years, but there was some concern that some pilots didn't know how to manually fly the airplanes anymore. So we pushed that always be ready to kick the automation off and take over. But I also saw something where I always called not just automation dependency, but complacency. I programmed the airplane to do this. It didn't do what I wanted it to, and it drove me into a deviation. Maybe I would get calls from the FAA that, you know, this aircraft had a altitude deviation. They were supposed to be at this altitude, not this altitude. Or they were supposed to go on this course, but they went on that course. And I'd have to go back and investigate these and talk to the crews. And a lot of them said, well, we told the, you know, we programmed the airplane to do this, but it didn't do what we wanted it to. And I said, well, at what point during your monitoring did you determine it's not doing what you wanted it to do, and then kick it off? And they didn't. Many of them become complacent and left it on there. So that was kind of the second thing that I think we can learn from this, is always try to be ahead of the vehicle, always anticipate what the automation is going to do or should be doing. And if it's not doing what you think it should be doing, turn it off. And then the final thing is, we've already talked about, is education. You've got to know how these systems work. You know, in aviation, it's great because you go back to do simulator training quite often and you get to practice it. If there's new changes or upgrades to the system, you know, we get them and we take them, you know, we either do a classroom on it, normally do a classroom, and then go into the simulator and do it. So I would say to the public, educate yourself on the systems, know the environment that they work in, know the environment they don't work in and don't engage in them, and then know the limitations in each one of those environments.
So what really jumped out at me in what you said there is that, you know, the technology that has defined autopilot doesn't sound like it's really ever meant to be completely left alone. It sounds like you're talking about a pilot maintaining certainly a level of engagement with the system at all times. And yet I think our mental model about what we're trying to achieve with automated driving is to just be able to be hands-off completely with the system. And you're saying that how many years into aviation automation? You must be decades at this point, and yet the pilot still has to remain engaged.
Yeah, I mean, if you look at it out there, you know, even a lot of the military drones are flown by pilots sitting like in a little simulator building, almost is what I call it. Yeah, are there some automated aircraft out there doing these things on their own program? Yes, but very limited. Same with the vehicles, right? We're seeing a couple of these, maybe some extremely slow moving shuttles like, I think there was one in Las Vegas, Nevada, that we actually had a accident with a truck, or a crash with a truck. And you know, but they very slow, very limited course that they were driving on. So you know, that's why I say we're not there. But even in aviation, you know, I don't see the FAA at this point, you know, even if we could program a passenger aircraft to do all the flying and take off from point A and go to point B, I don't see them letting that aircraft go with passengers on it without at least one person up in the front ready to take over if something happens. So I think vehicles, cars are in the same boat at this point.
Yeah, well, that's really interesting because I don't think that we have a process, you know, where you can achieve that level of driver training to understand the automation at that level. And I think it's such a interesting challenge, and that's one thing that we're studying at the AAA Foundation for Traffic Safety is how do you educate people about this? Because the people who I know who have some of these technologies in their vehicles kind of wing it. And that doesn't sound like that's how pilots are introduced to these technologies, and we're really borrowing a lot of that from the aviation industry. So I think that the consumer education is going to be a very, very big challenge. And honestly, how to engage people and get people to pay the kind of attention to these technologies that they need to, I agree, is a big challenge, and that's something AAA is really committed to solving if it's solvable. But I do think it's going to be a challenge. I want to give our folks who are with us today an opportunity to get in here and ask questions if they have some. So we'll go ahead and I'll watch for any questions that come over the chat. But let me just go ahead and kick us off here and ask you a question. We've been talking about a little bit about policy and training and how maybe the testing and development of these systems needs to be regulated. But sometimes avoiding bad policy is just as important as enacting good policy. So in your view, what is your advice for state and federal policymakers in terms of policy moves to avoid? Because we don't want to stifle innovation. And but what's that fine line? What would be kind of a bridge too far?
Well, that's a good question. Yeah, you know, I'm not a big policy guy. You know, even in flying, that I look at the federal aviation regulations in flying as I look at those as the bare minimum. The minimum bar is set down here, and those are hopefully operators go above and beyond that. What's bad policy? You know, we're not the regulator, like I said, but my concern is having no policy at all or no standards as far as you know, what's acceptable. How do we warn a driver that there's a vehicle in front of them, or that they need to be, you know, they're going to collide with them very soon, or they need to be braking, or the automatic emergency brakes are going off. So I think not doing anything that we're doing now, having no standards and having no testing procedures for any of this new technology here in the US is, to me, that's bad policy at this point. And I'm just afraid a lot of these manufacturers are going to go off in a lot of different directions, and things are going to be dictated to us down the road that may not be safe for pedestrians and motorcycles and bikes and other drivers on the road.
Well, thanks for that. We have a question, and the question is, in the Tempe, Arizona crash, was the factory Volvo safety system, which includes pedestrian detection, was it disconnected? And if so, how can we balance the need to prioritize crash avoidance while still avoiding false positives?
Can you read the first part of that? I'm sorry, my computer cut out then.
Oh yeah, no problem. In the Tempe, Arizona crash, was the factory Volvo safety system, which includes pedestrian detection, was it disconnected? And if so, how can we balance the need to prioritize crash avoidance while still avoiding false positives?
Okay, I will tell you, I was not on the board at that time, and I haven't been through the complete docket, but I do know it did register the pedestrian, It had some issues there trying to determine, I think, was it a pedestrian? Of course, it crossed perpendicular to the way the vehicle was going. So in the end, it did not register it as a hazard until about a half second before the vehicle struck the pedestrian. I think I remember looking at that data specifically. So now whether that was factory, I'm sure, it did have that module, whether it was a factory module or I'm sure it was more of a testing module, I would think by that point.
Mm-hmm.
I couldn't tell you exactly that, but yes, it did eventually determine that the pedestrian was a hazard, but it was too late.
Oh, tragic. How concerned is the NTSB about possible hacking of the telematics in self-driving vehicles, including truck caravans?
Boy, that's a good question. There is concern. I've been doing a lot of reading about it, but I'll be honest with you, at least as far as I'm concerned, my jury's still out. I'm not too sure I have enough information to determine that. I'm not very smart when it comes to the IT world, although I have flown some technologically advanced aircraft and vehicles, but I know it's a concern on the FAA side of the house. I'm sure it's a concern here with vehicles, but I don't know. I'll have to look and see if we're looking very closely at that from the NTSB side of the house. We'll have to maybe pass some information back through AAA to your members there.
Yeah, happy to do that. Yeah. Well, while we're waiting to see if we have another question, I'm going to kind of give you the positive question. Well, let's see. I have another one. How do we address law enforcement concerns about policing automated driving vehicles?
That's an excellent question. I think a lot of that's going to go to the individual issues out there, like speeding. Obviously we want positive enforcement on speeding to slow people down. We'd love to see states enact, seatbelt laws for all occupants, right? I know that's not necessarily as far as the automated vehicles. That's a difficult question. I don't know if anybody's looked at it. I don't know if AAA, have you guys looked at any of that yet?
No, I don't know that we have specifically on the question of enforcement. But yeah, I agree. It's an interesting question. So,
well, I got a question for your viewers, if you don't mind.
Yeah.
Is what are their concerns as far as automated vehicles go? And is there an area they think that maybe needs more focus on, that we need to focus on more? Maybe not just AAA, but maybe the NTSB. Are we missing something?
Yeah, I don't know that we have a lot of particulars on what it is about automated driving that still does have the majority of people who answer our survey has them concerned. But I think it's the unknown. And I think, though, that it is interesting. I believe that people kind of separate this notion of a self-driving vehicle from the technologies that are in their cars today. And I don't know that they realize that these are building blocks and that you have a certain amount of control. Indeed, you've talked today about you need to have a certain amount of control and vigilance over even the technology. We definitely saw with the Arizona crash, when we had done the survey question before that, we had been seeing the concern about driving in a self-driving vehicle, per se, going down. After the Arizona crash with the pedestrian killed and the Uber crash, it spiked up again. It was a very big dramatic increase. And so when you said earlier you didn't know if that number had been related, we certainly believed that it is. I think that one thing that we do know, probably relative to driving and certainly flying, we know this, is that lack of control scares people. And I think that that's kind of what it comes down to with the whole package and the notion of a self-driving car. It's just lack of control. And I think that that's part of what makes people afraid to fly too. So it seems to be a little of that.
I can appreciate that. I don't like riding in the back of an airliner. I'd rather be up front controlling it myself.
Yeah, see, that's right. You like the control. So I guess that's it. I have another question. How about winter weather? Is the assistance technology, does it work in the snow or will it fail in the snow?
That's an excellent question. I don't know the specifics of all the different technologies in the cars out there, but I do know, when you're looking at like camera systems, reduced visibility, contaminated roadways, those are all going to be an issue. We already saw that with the lane assist with the Mountain View, California Tesla accident, that basically the left lane striping had worn away and there was no striping in the gore area. So the vehicle just started moving to the left. It may have been thinking the left side line of the lane was actually the verging highway, the ramp on the left side. So that's a concern. Anything that can affect one of these sensors, and weather is definitely one of them, is got to be a concern. And developers need to definitely develop their systems to handle that. Or I don't know, what are they going to do? Kick it off and say, hey, I can't see the lane, I can't see the road anymore, I'm not sure my ranging, I'm not sure. There's got to be a way to kick the system off and alert the driver that you have manual control now. I can't accurately assess the environment out there. So that is a huge issue. And I honestly haven't seen a lot of research on that as to how well these sensors do in snow, rain, reduced visibility. I'm sure it's an issue. It has to be an issue.
Yeah, I would think so too. Okay, I think we have time. We're really close to our time. Let's do one more question. Has the NTSB made recommendations to states to not weaken traffic safety laws for AVs specifically? For example, allowing texting and phone use only in AVs.
We have made some recommendations out there. I can't tell you specifically on some of those, but I will tell you in some of our accident investigations, we actually were able to determine, where they were carrying maybe several passengers. We could actually, through some of our investigations, determine who was on the phone or who was texting and who wasn't. Isn't that amazing how good some of our investigators are and our labs are to determine that? That's just amazing. And I would tell you, that is one of my biggest concerns every day when I drive down the road is the distracted driving. That is my number one issue. And I get angry when I see people out there. When I just drive the few miles to and from work, each way, I don't see one person texting or using the phone improperly while they're driving. I see multiples each way, and it makes me angry because they don't understand what risk they're doing, not just to themselves, but to the rest of us out there on the road by not paying attention to the road. So please, I would put away the phones while you're driving. I mean, I don't answer the text and I don't answer a phone while I'm driving. And if I need to, I get off the road, pull over in the parking lot and do it. So we all know it, but it's so tempting to pick it up, but just don't do it.
Yeah, absolutely. It's not worth it. Absolutely isn't worth it. Well, we're at time, and Member Graham, I've really enjoyed this chance to talk to you. AAA is pro-innovation. We're pro-technology because we do believe that there's great potential to improve safety. On behalf of AAA and AAA Northeast, I want to thank you for taking the time to talk with us. AAA and the NTSB have enjoyed a long and productive collaboration, and we look forward to working with you and the excellent staff at the NTSB to reduce crashes, injuries, and deaths on our nation's highways. Thanks so much.
Thank you, Kathleen.